Hello. You are about to embark on a journey that most high school students do get to go on. We're solving quadratic equations by factoring. This is awesome, okay? This is big time. This is huge. This is Kajunga, okay? What we want to talk about today is solving quadratics by factoring, okay? What we want to do is we want to be able to write the equation in standard form and set one side of the equation equal to 0, factor the polynomial, apply the zero product property, solve the resulting equations, and then check the solutions for reasonableness, okay? So the first thing I want to do is is solve this equation, okay? And so what I want to do is I want to get all of my values on one side of the equal sign and then set everything equal to 0. So what I'm going to do here is I'm going to subtract by 16x on both sides, okay, and then subtract by 30 on both sides, okay, and then minus 30. All right, so as a result, what I get is I get x squared, okay, and then minus 16x, okay, and then I get negative 6 minus 30, which gives me negative 36. Okay, and what I do is I'm going to set this equal to 0. Now, in order to solve this, I need to factor this equation. Okay, so what two numbers add to negative 16 but multiply to negative 36? And those two numbers would be negative 18 and 2. So I'm going to rewrite this and factor this as x minus 18 and then x plus 2. And set that equal to 0, okay? And so what I have here, just think, okay, these two numbers, you add them together, you get negative 16. You multiply them together, you get negative 36. And that's all you need to do, provided that the leading coefficient is 1, okay? So what I want to do then is apply the zero product property, okay? So, setting this equal to 0 is step 1, okay? Factoring it is step 2, okay? But step 3, what we want to do is set each of these equal to 0, all right? So I'm going to set x minus 18 equal to 0, and I'm going to set x plus 2 equal to 0. Okay, and the reason is that either one of these values, once it's factored, can, which one of these is going to be 0 would make the other one 0, all right? So what I want to do is solve both of these equations. And if I have x minus 18 equals 0, then I add 18 to both sides, and then I get that x is equal to positive 18. Okay, so that's one of my solutions. Then the other one is that I set x plus 2 equal to 0, okay, and subtract by 2 on both sides, and I get that x is equal to negative 2. So these are my two solutions. So these are my solutions that make this equation true, okay? So x equals 18, x equals negative 2. Now what I want to do is I'm going to then graph this equation. So let me put that in a graph, and let me show you what this looks like graphically so we can kind of take a look. Okay, so what we notice here, I've graphed this quadratic, and what I've done is I've calculated where does this graph cross the x-axis. So what you guys can do is anytime you're trying to solve one of these quadratics, you can always graph the equation and see at what points it crosses the x-axis. So we got positive 18 and negative 2, and those are the two x values that I got algebraically here, okay? So either way you do it, that's the process, okay? So let's go ahead and let's try this next one, okay? And I want to get all of my values on one side, and so I'm just going to go ahead and subtract 12x, and subtract 5 from both sides, so minus 12x minus 5. And so what I'm going to get over here is I'm going to get 12x squared minus 12x, and then I get minus 9, okay? And I'm setting that equal to 0. Okay, now that's step 1, just setting equal to 0. Now I need to factor this, okay? And factoring this is a little bit trickier. And you know what? I'm going to do the... I'm just going to do the box method, or you know what? What should I do? Let me do this. Let me do the x method on this one. And so I'm going to take 12 times 9. So 12 times 9, 12 times negative 9. And that's going to give me negative 108 okay? And then I need to put in my middle term, my b term, which is negative 12, okay? So now what I need is I need two numbers that multiply to negative 108, but add to negative 12, okay? And those two numbers, it might take you a bit to kind of figure that out, but two numbers that multiply to negative 108 and add to negative 12, that would be positive 6 and negative 18. Okay, if I multiply these two numbers together, they give me negative 108, and if I add them together, they give me negative 12. So what I'm going to do is I'm going to do this. I'm going to split this up and do 12x squared, and then minus 18x, and then plus 6x, and then minus 9, and set that equal to 0. Okay, then I'm going to group these together and find a common factor. Between 12 and 18, I can factor out a 6 from that. And so when I factor out a 6, so let me do that real quick. If I factor out a 6, 6x, then I'm going to be left with a 2x minus 3. Okay, and then here I can factor out a 3. All right, so if I factor out a positive 3, then I'm left with just a 2x minus 3, and that's equal to 0. Now what I have is I have a common factor here of 2x minus 3, and so I'm left with, if I factor out a 2x minus 3 factor, then I'm left with 6x plus 3, okay, and that's equal to 0. Okay, now this is factored, okay? This is where, we kind of struggle factoring-wise, okay? And so what I'm going to do now is I'm going to set each of these equal to 0 and then solve for x. Okay, so I'm going to do 2x minus 3, set that equal to 0, and I'm going to set 6x plus 3 equal to 0. And so if I solve this for x, I'm going to add 3 to both sides here and here, so I get 2x is equal to 3. I'm going to divide by 2 on both sides, so then I get that x is equal to 3 halves. So x is equal to 3 halves, okay? And then here I'm going to subtract by 3 on both sides, so I get 6x is equal to negative 3, and then I'm going to divide by 6, and then divide by 6, and so then I get that x is equal to negative 1 half, okay? So we've got those as our values, as our solutions, and that's all we're doing, okay? These are our solutions. But let's just check graphically, okay? Let me graph this equation here, 12x squared minus 12x minus 9, and then we'll see what we get. Okay, so if we take a look at this graph, okay, what we notice is, we were looking for the numbers, 3 halves and negative 1 half, and these are in decimal form. So negative 0.5 is negative 1 half, and then 1.5 is the decimal version of 3 halves, okay? And so we did, in fact, do this correctly, and so, that's just kind of what we're looking for. So hopefully, we're able to, kind of get the process down and see how to do this. Okay, let's take a look at the next one. This is the equation 4x squared minus 7x is equal to 3x plus 24. What I want to do is I want to get everything on one side of the equal sign, and then I want to set it equal to 0, and we'll factor and we'll solve. So what I want to do is I'm going to subtract 3x from both sides, okay, and I'm also going to subtract 24, all right? So as a result, we get 4x squared minus 10x, negative 7x minus 3x gives me minus 10x, and then minus 24, and then I'm going to set that equal to 0, okay? And one of the things that you can do here that I didn't talk about in the other one is see if you can factor any numbers out to kind of help you with the factoring of this. When we have 4 and negative 24, if we multiply those together, it's going to be kind of a big number. So what I want to do is this. I'm going to factor out a 2, all right? So if I factor out a 2, then I'm left with 2x squared minus 5x minus 12, okay, and set that equal to 0. Now all I have to do is factor this trinomial, okay, as opposed to using those big numbers. So I'm going to do the x method again, just because I kind of like that method. Or, let's do the box method, just because. Just do it something different, show you guys. All right. And so what I want to do is I need to put my 2x squared here, okay, and then I need to put my negative 12 down here. and then whatever I need to factor in, these two values need to add up to negative 5x. So what I'm going to do is this. I'm going to put a 2x up here, and then an x over here. Okay, and then this one's a little bit trickier because, you've got a 12, and a lot of things multiply to 12. But let's do this. Let's do, let's just do like, I'm going to do negative 4. I'm going to do x minus 4, and then 2x plus 3. Okay, and here's why. All right, if I do 3 times x, that's going to give me a positive 3x in this box. Okay, but if I do negative 4 times 2x, that's going to give me a negative 8x in this box. And if we add those together, then that's going to give me negative 5x, okay, which is what we were looking for, all right? So I think that's a little bit easier to do, but that's just me, okay? If you want to do the x method, you could do that. But in any case, we have factored this, and as a result, we have 2 times the whole quantity, and let's do 2x plus 3, and then x minus 4, and we're going to set that equal to 0. Now, to solve this for x, what I want to do is, first thing I want to do is divide the whole thing by 2, and divide it by 2. So when you factor out that 2, when you divide by 2, the 2's divide out here, and then you have 0 divided by 2 on the right side, that's just going to give you 0. So you're just going to end up with the same thing, 2x plus 3, and then x minus 4. And that's all equal to 0, okay? Now I need to set each of these factors equal to 0, okay? And so what I'm going to do is this. All right, I'm going to make a line and draw it up here. So I'm going to do 2x plus 3, set that equal to 0, and then x minus 4, set that equal to 0. So and x minus 4, set that equal to 0. So then I'm going to subtract 3 on both sides, and so I get 2x is equal to negative 3. Divide by 2, divide by 2. So I get that the value of x equals negative 3 halves, okay? And then over here I'm going to add 4 to both sides, so then I get that the value is x is equal to positive 4. So these are my solutions, okay, to this equation, all right, and to this quadratic. And what I want to do is I'm going to graph this original thing, 4x squared minus 10x minus 24, and make sure that we do get these values. So let me do that real quick. I'm going to move over here. And would you look at that? Negative 1.5 and 4. And that's exactly what we had. That's what we wanted to get. Okay, negative 3 halves is the same thing as negative 1.5. And then we got x equals 4, and that's that point there. So you can verify always graphically if you're doing it right. So here's what we got. Okay, let's take a look at the next one. It says a rectangle. A rectangle has a length. So this is some application stuff. A rectangle that has a length that is 2 inches greater than its width, and its area is 168 square inches. The equation x plus 2 and x equals 168 represents this situation. So let's just draw a quick picture here. All right. So I'm going to call this x, and then this is x plus 2. Okay, and this is my length, this is my width. If I take length times width, then that's going to equal the area. Okay, now my area is 168. So if I take x plus 2 times x and set that equal to 168, then that represents, this situation. Okay, so what I want to do now is distribute this x here, and so I get x squared plus 2x and set that equal to 168. All right, and then I'm going to subtract 168 from both sides. So minus 168. All right, so then what I get as a result is x squared plus 2x minus 168 is equal to 0. Okay, now the question is I need two numbers that add to or that multiply to negative 168 and add to 2. Okay, so let me figure that out for just a second. And after a little bit of calculation, what I figured out was that that's going to give me x plus 14, okay, and then I've got x minus 12, and set that equal to 0. Okay, now here's where it gets a little tricky, is because when I set both of these equal to 0, if I set x plus 14 equal to 0, and if I set x minus 12 equal to 0, If I solve this for x, I'm going to subtract 14 from both sides. So I end up getting over here that x is equal to negative 14. Okay, then over here, if I add 12 to both sides, I get that x is equal to 12. All right, so what we have to realize is that which one of these would be one of the side lengths of the rectangle? And the answer is that this answer here would be the most reasonable answer, okay? The reason why, okay, so our length, length is equal to x and our width is equal to x plus 2. Okay, the reason why is because if I were to plug in negative 14, I can't have a negative length. Okay, so I have to choose the positive one because my distance, I'm going to write this, that distance is positive. Okay, and so then our dimensions, if I plug that in, my length is equal to 12, and then if I take 12 and add it to 2, then my width is going to be 14. So my dimensions is going to be a 12 by 14 rectangle, okay? And that's how you do something like that. All right, on the next one, it says the product of two consecutive positive integers is 462. What are the two numbers? So what I have is I have the product of two consecutive positive integers. So if I let my first positive integer be x, okay, and if I multiply that by another number, that's going to give me 462. Now, if I have a consecutive number, okay, if I take that number x to get my next number, I would just add 1, okay? So you'd have this problem here of x times x plus 1 is equal to 462. And we got to figure out what those numbers are, okay? And this is a problem that's pretty common on the ACT or SAT, so this is a good one to know. So what I'm going to do, I'm going to distribute my x. So I get x squared plus x, and that's equal to 462. I'm going to subtract by 462 on both sides, so minus 462. So I'm going to get this. I'm going to zoom in here so I've got some room. But what I end up getting is I get x squared plus x minus 462 and set that equal to 0. Now I need to factor this. I need to find two numbers that multiply to 462, okay, but add to positive 1. So let me figure that out for just a second. All right, so after a little bit of work, I found out that those two numbers are going to be x plus 22 and then x minus 21, okay? If I multiply these two numbers together, I'm going to get negative 462, but if I add them together, I'm going to get positive 1. So then what I get is I get, I got to set both of these equal to 0. So I'm going to do x plus 22 is equal to 0. And I'm going to do x minus 21 equal to 0. Okay? So if I subtract 22 from both sides, okay, I get x is equal to negative 22. All right? And then I'm going to get that x over here is equal to 21. So positive 21. So let's go back and look at the two questions. They have to be positive integers, okay? And so what I want to do is I want to choose the number that's positive. So my answer, are integers, all right, that would make this true would be 21 and 22. All right, those are the two numbers that we've got, all right? Okay, on the last part of this video, what I want to talk about is that, before we apply the zero product property, guys, we must set the equation equal to 0. Okay, and the reason why is because of this. If you had, this value here, AB, the zero product property means that if you have two numbers being multiplied together and you get 0, then either A is equal to B, A is equal to 0, or B is equal to 0. Okay, and we take these quantities and apply those quantities as the same thing. Okay, but the problem is that you can't always get that, all right? If you have the same, binomial or binomials, product of these two numbers equal to an actual number, okay, then what can you determine about the values of A and B? They could really be anything. Okay, they don't have to be 0. They could be equal to a number of things. The product of A and B, one of them doesn't have to be 0. One of them doesn't have to be 2. One of them doesn't have to be 6, okay? So you have to set it equal to 0 because 0 has that special property that if you multiply two numbers together and get 0, then one of them has to be 0. Okay, so that's all I've got for this one. I hope you enjoyed it. This is a really good, fun stuff. Make sure you've watched this video and that you're going through all the same steps that I'm going through. Okay, see you later. Bye.